Hi everyone, how are you doing? Can you hear
Good, how are
me?
you? Yes, we can hear you.
Good, good. Thank you. I'm back. Came back last night and sorry to keep you waiting. But now that we are here, um, we're going to get started, jump back into the exam, and I'll be meeting with you a few times before we go for the exam. Okay? So, meeting again tonight. So, if you want to join, small session Q&A. I've kept it open to everyone, but we can go from here. All right, so you guys are ready? Please put your videos on. I don't see anyone except for myself. I want to see your lovely faces. I haven't seen you for a while. So everything else is going good? Yes. All right. Dios are here as well. Yeah, I see Mara there. Yeah. Okay. All right. So my questions are coming. Are you ready? Yes. All 3 weeks? Okay. So they'll be random. Don't worry about that if you don't know them yet, but still just prepare yourself for the ordeal. Okay. All right. So tell me, which hormone do you need for pancreatic enzymes? Go ahead, Sadaf. Sadaf, you are on mute. You want to go? I thought you had a hand raised, no? Okay. Anyone else? Yes, Miret, you are absolutely correct. CCK is the enzyme. So CCK potentiates which enzyme?
Is it secretin?
Sectin. Very nice. Okay, what's the function of sectin?
To increase secretions from the liver and the pancreas.
Beautiful. So increase secretions. Um, yeah, mainly pancreatic secretions. What are the roles of ductal cells for the salivary glands? Yes, Pursum.
So the ductal cells modify the. Sorry, I have another screen here. The ductal cells modify the salivary secretions so that they make it more hypotonic because they're initially isotonic. So as they go through the ductal cells, the ductal cells reabsorb sodium and secrete potassium into the saliva and
Beautiful.
bicarb.
So if flow rate
Yeah.
for salivary glands is increasing, what do you think is happening to the composition of the saliva? So Bursum just mentioned that the acinar cells for salivary glands, they give you isotonic saliva, right? And ductal cells, they are working on it to make it hypotonic. That's at the low flow rate. So what's going to happen if high flow rate is there? Less hypotonic. Yes, Merit. Less filtration. So what does it look like now? Can you please raise your hand? Sometimes I'm okay. All right. Some of you in library. Okay. Yes, Prism, go ahead.
So, if you had higher flow rate, you would have a less hypotonic solution with regards to the salt, but the bicarb production is separate from that. So that actually increases with increased flow rate. So if you had increased flow rate, you would have more salt in the saliva because you didn't have time to reabsorb it, but you would also have more bicarb because that's increased.
Beautiful. Yeah. As the flow rate is increasing, it's going to become isotonic, right? Because sodium is just being retained back there. And then, as I said, Bursum mentioned, excellent, excellent, Bursum. Thank you for chipping in. So you're going to have more bicarb, whether it's salivary or pancreatic secretion, if there is more parasympathetic stimulation. Don't forget that, ever. Okay. All right, so let me go back. What do you think the biggest stimulant is? Which hormone is will be secreted if biggest stimulant is hydrogen ion in the duodenal area? Yes, Alicia.
Is it secretin?
Secretin will be released, and what does it do?
So it increases the pancreatic bicarb secretion to neutralize the hydrogen ions.
Yes. Another function of it? Another function of, yes,
It inhibits
Amanda.
its gastrin. Oh, I'm sorry.
Go
No,
ahead.
it's okay. I was going to say the same thing, that it'll snub the effects of gastrin.
So it snubs the gastrin release, right? So there is no more hydrogen ion that are coming in there. Great. Okay. So far we are doing really well. So another question is, I'm just thinking, how do H. pylori exist if there is infection? How do they inhabit in stomach? Yes, Deborah.
So H. pylori specifically releases a urease, which allows it to remain in the environment. It also breaks down the mucosal membrane and it removes all the protective barriers. So it continues to perpetrate its actions in the gastromucosa.
Very nice. You are there, but give me the mechanism. Okay, enzyme urease is there. How does it survive those conditions? What does urease do? Yes, Deborah.
So it neutralizes the environment
Yeah, I mean, how?
through
You're
its
right.
ammonia secretions,
Two, say it again, please.
through its ammonia secretions.
It makes ammonia
Urease
from
converts into ammonia.
urease converts what? To ammonia. Urease converts urea to ammonia. Okay, so just keep that in mind, and that's how it neutralizes the area. It's very acidic environment. As you know, the pH is down to 2 almost with the acid release. So yeah. If someone is on PPIs for a longer time, what do you think is going to happen with the gastrin secretions? Beautiful, because PPIs are snubbing the main door, right? So stomach may think that we need more acid because there are no acidic environment there. Your mechanoreceptors will pick that up and bring you more gastrin release. Okay, wonderful. We are doing very well. Okay. Chronic pancreatitis. What do you think it impacts on? Someone is having chronic pancreatitis. Yes, Parambir?
Someone with chronic pancreatitis, would they have problems with digesting lipids or fats?
Yes,
Okay.
that's correct. What else? Anyone else? No answer? Yeah, so that you're right. But Parambir just mentioned lipid. digestion and absorption. Yeah, the patient will have oily diarrhea. Very nice. What else? No. I mean, yes, eventually, yes. If it's getting to the endocrine part of pancreas, yes, that's correct. Lipase, co-lipase is gone. Very nice. What else? What about Sadaf is writing something? No, cystic fibrosis, we didn't go there yet. First, we're just talking about chronic. Yes, Alicia?
Does it have something to do with trypsinogen release?
Yes, I mean, yes.
Okay.
If I said chronic pancreatitis, that means all the pancreatic enzymes and enzymes for the proteins as well, right? Enzymes for your carbs as well. They're only worked a little bit up to your stomach area. Rest is all happening in your small intestine. So keep that in mind. Everything will be impacted if we say chronic. Now let's go to cystic fibrosis. How do you think that cystic fibrosis will impact the digestion? Why? What's the reason, and which of the proteins, carbs, or lipids, what are impacted by cystic fibrosis? Sticky mucus, yes. Why? How did that happen, first of all? Yeah, so the cystic fibrosis chloride channel, CFTR channel, is not working, right? So you're not pouring enough chloride into the lumen, so your sodium and water is not following that, so you're not making the secretions as aqueous, right? It's very mucousy. Now what's happening? Patient has clogged ducts, right? They're not able to take those enzymes down nicely into the small intestinal area, and that's how you are impacting all the digestion, not just one type, but all kinds, like talked about earlier. Now, cystinuria. Which digestion is impacted in cystinuria? What is it? Cysteine. Yeah, very nice. Alanine, lysine. Oh, great, JP. Thank you. J. Yeah, so dibasic amino acids. So basically protein, absorption, right? Digestion was okay because you had all the pancreatic enzymes there. But since they don't have the transporters which are absorbing these dibasic amino acids, right? So they won't be getting picked up. So here, absorption. You should keep that in mind, right? Okay. What kind of bilirubin you will see in the blood system if the bile duct is blocked? Conjugated or non-conjugated? And how and why? Jay, you are right. It's conjugated, but you got to explain me. Are you in the library? Oh, we have Abram here. Yeah. Okay. Go ahead,
Hello,
please.
I'll try to explain. So I think it's conjugated because it's already went to the liver. So it's already been made because that's the common hepatic duct. And then this it can still be stored in the bile, but it can't be excreted. So it's still going to go through its conjugation form because nothing's technically wrong with the liver. It's the common bile duct after. That's the
It's the
problem.
bile duct which is blocked, right? It's post-hepatic problem that I just mentioned, right? If the bile duct is blocked, that means the stone is lodged there, which is not letting the bile go into the intestine yet. So, but bile pigments have been conjugated at the liver site by the hepatocytes, right? So it's all good. Hemolytic anemia. What kind of bilirubin you will see in that scenario? Yes, Alicia.
You get lots of unconjugated bilirubin because it can't bind to albumin fast enough because you're having all of the massive hemolysis.
Beautiful. It's massive. It's a lot of RBCs that are being attacked and hemolyzed, right? So basically, what is bilirubin? That's a byproduct of hemoglobin, right? When your red blood cells are being worked on in the liver, the recycling of these components will take place, right? So byproduct is bilirubin, and that has to be now conjugated in order to put into the bile juice and then go further down into the intestine. But in case of hemolytic anemia, now the cells are destructed at a very fast pace and liver can't keep up with the conjugation that has to be done at the liver site. So please, they're seeming very small things, but you can assume questions, orient them in a clinical STEM. Has everyone done the QBanks? QBank is done? Yes? If you haven't done those, I think that should be your TA review should be coming to you today. So you should be just going over those questions as well. Let me know if there are any problems. I can handle those. How do you think that the slow waves are generated in your gut? Yan, I didn't hear from you today. Slow waves, generation of slow waves. How is it happening?
Through the NA channels, being an increase in NA.
Yeah, but how? Which cells do that? The calcium does the depolarization. That is superimposed on slow waves. Yeah. Lauren just sent it. Yeah, Lauren.
Cells of Cajal.
Yeah, interstitial cells of Cajal. Those are your pacemakers of gut. They're going to start your slow waves. And basically, they are, I told you guys this. So if you go into my lecture slides, you will see that how these cells are synapting both towards the longitudinal muscle cells and towards the circular muscle cells in order to impact the mobility. So whenever on these synapses, further there is ACH release or the neurocrine release, which is going to impact the contraction magnitude. The number won't change. The frequency is not going to change. So keep that in mind. If you see questions like that, you got to be ready. Okay. Has everyone gone over the Zoom recording, the exam Zoom recording from spring? Just keep in mind the acid base is not on this exam. So you will see at the end that's going to be with your renal. But rest of the GI questions, you should definitely go over. Yes, we can, Lauren. Do you mind if I do it tonight? Because I want to ask you more questions and then have more people attending. So, in case they are having issues with tonic. Yeah. Okay, so my next question is, what is happening in lactose intolerance? Yes, Parambir.
And lactose intolerance, the disaccharide, lactose is not being broken down by lactase, and it's remaining on the villi, not villi, but like in the intestines, and which is leading to, like, since it's not being degraded, it causes like osmotic imbalance in the osmotic pressure, I think.
No imbalance for the pressure there. It's basically you have osmotic active particles which are sitting. So it's basically sugar sitting in your gut, right? So if sugars are sitting there, it's going to hold as much water because it's not getting degraded only way you can absorb your sugars from the gut is if you have it in the form of monosaccharides, and lactose is not the one, right? Because there is no brush border enzyme, lactase. So your sugars is sitting and it's going to cause the osmotic diarrhea. Now tell me about secretory diarrhea. How is it different from osmotic diarrhea? Who will take that? Yes, Alicia, please go ahead.
Okay, I'm gonna try. Might not be 100% correct.
It's fine.
An
Thank you.
example, maybe like cholera turns on the CAMP-dependent chloride channels, and so as chloride goes into the lumen, it pulls water and sodium with it, and then you end up with excess secretions and secretory diarrhea, maybe.
Yeah, so basically what is happening, the chloride channels, they are permanently turned on by toxin binding to the G proteins, right? And G proteins are the ones which are needed to activate the adenylate cyclase mechanism to produce CAMP. And CAMP is something that you need to open the chloride channels, right? So if it is permanently turned on, then you have chloride being poured out, tons of it in the gut, right? Which is basically making the lumen of the gut. If you look at the electric charge, it's going to be more negative, right? So if you have more anions sitting in the gut, your sodium is just going to follow that, right? To make it, to neutralize it basically. And then water is just going to follow sodium. So patient is losing their own secretions. That's why we call it secretory as opposed to the other diarrhea, which is basically osmotic. We talked about that. Or if patient is just losing any GI secretions, which are still sitting in the gut, obviously that's common diarrhea that anyone would have, but you are still not losing your own secretions, which is happening in case of secretory diarrhea when these toxins, which are highly toxic, and go bind to the G proteins and let these chloride channels open and letting you lose more of your secretions from inside of the body, and patient will be losing their extracellular fluids so fast. And that's how, the blood pressure is dropping, and patient can be go into a bad situation very quickly with these toxins. Okay. All right. My next question is, what will be a stimulant to secrete GIP? Quick stimulant. Yes, Merit, you are absolutely right. Oral glucose. So what is the difference between insulin secretions and GIP? Anyone? When do you think insulin is also helping you absorb your glucose, right? So what's going on here? Can anyone explain what's the difference between GIP and insulin that way? Yes, you are correct, Jay. There are three major stimulants, but oral glucose is the major stimulant for GIP. This is the only hormone which gets released in stimulus to all three. Only hormone. But you didn't give me the answer yet. Difference between insulin and GIP. Which situation you'll have insulin release? Great, but what does it do? What's the name, full name of GIP? And what do you think it does? GIP only respond to oral glucose. Very nice. How about insulin? It's glucose insulinotropic peptide. Okay, wonderful. We also call it gastric inhibitory peptide, by the way. So keep that in mind. And there is some correlation to that. Can anyone tell me why we call it GIP? It boosts insulin release only when glucose preset beta cells. It does boost insulin release. Yes, you're absolutely right. You still didn't give me the difference between insulin and GIP. That means you haven't done the clicker questions yet. Thoroughly with the speaker notes. Anyone? It slows down gastric emptying. Very nice, Jay. So which one is the most potent stimulus to work on the gastric emptying? Which hormone? CCK, not gastrin. Jay, not gastrin. CCK is the main one. And why do you think CCK is the main one? My other question still stands. I'm going to come back to that in a minute. Why do you think CCK is the most potent hormone? Yes, Deborah.
Is that because it takes time to digest the fats?
Beautiful. So, if you are emptying stomach out too fast, when CCK is being released, it's going to make sure that the fats are coming out in the intestine slow enough so the enzymes can work on the fats really nicely. Yes, everyone clear about that? Yeah, got it. Okay, now going back, what's the difference between insulin and GIP? Yes, GIP is the name for incretin, right? It boosts insulin release, right? As the name suggests, increased insulin, incretin, right? Yes, Pursum.
I'm not too sure, but I believe that GIP is only stimulated by oral glucose. So that means that you could essentially get the same effects by like IV injection of insulin and but you wouldn't be able to do the same vice versa. So GIP is specifically only released with oral glucose.
Yeah, anytime you are eating something sugary, your GIP is going to get released. But if you have glucose sitting, which is acting as a sensor on your beta cells to release insulin out of the beta cells, okay? So IV is the answer, okay? IV versus oral. IV for insulin, oral for GIP. So keep that in mind. Now give me an explanation for GLP. What does it do for you? There's so much hype about GLP these days. So what do you think is going on? You gave me the answer in class in fragments, so I'm looking forward to that. It increases satiety, right? So satiety is the feeling that you feel full, right? You feel full. It slows down the gastric content being worked out, right? It's going to slow down the gastric emptying again. It is also an incretin. It works to release insulin again. And basically, it let the patient feel that they are full. It's going to increase the satiety feeling. So it's very important keeping in mind nowadays the role of GLP. But basically, its main function was initial days that it was using for it was being used for diabetes, right? This peptide was being used in therapeutically, actually. It was being used, but now people are using as a, losing weight, basically. Okay. I see that you guys are not there how I want you to be. I mean, we are doing it, but I still feel I'm not getting the responses how I should be getting. I'm just hoping that you are working on it. So a few more things, and then we'll probably call it for now, and then I'll meet you guys later tonight again. Let's go to the digestion and absorption more. Where do you think that how do you think your water-soluble vitamins are being absorbed? How? What's the mechanism? Very nice, Jay. Sodium vitamin co-transport. Beautiful. And that's going to be for your water-soluble, right? And then what is happening with your fat-soluble vitamins? Fat-soluble vitamins. Yes, Gwen? Yeah? You are on mute.
Oh, can you hear me now?
Yes.
Okay, so if you don't have any like biosalts, you can digest you can't absorb, sorry, the fat soluble. So
Bile juice is one factor. Very nice. Okay. What else? Because you need to change them into micelle, right? And micelles will be the only form to absorb your fats, right? So yes, you are correct. I can bring this question another way. Why do you think that the people will have steatorrhea or oily diarrhea? Give me all different reasons. And I think I gave you like 7 or 8 at least. So if you reiterate back, okay, pancreatitis is the one where enzymes are not being released, right? Lipase is not working on fats. Very nice. Zollinger Allison. Alicia, you got to give me. So when you write something, let's go one by one. So we see a couple of them there. Zollinger Allison, what do you think is happening?
Because the increase in gastrin is inactivating the pancreatic hormones or the pancreatic digestive enzymes, so the lipase, so you can't break down the fats.
Beautiful. So just keep in mind, not your pancreatic proteolytic enzymes. We're talking about your lipases. They work under certain pH, right? It has to be alkaline, at least between 6 to 8. But if someone is having gastrinoma, the tumor is there, right? Which is producing this patient a lot of mutated gastrin, which is working on the G cells to give this patient more and more acid. Now, that acid, when it's coming to the duodenal area, it's basically inactivating that lipase enzyme, so fats are not being worked on. Okay, I have a couple of other things here. Bile salt issues, Kate has said. Yes. When do you think the bile salt issues can be there? Different reasons, Kate.
So usually with bile salt issues, it will not be able to digest the fat properly. So it will
That's
release the
correct.
oil.
That's correct. But when do you think that there will be bile salt issues? Which
If
examples? Go ahead, please.
so like the tropical spews and the chronic pancreatitis.
Well, let's not go there yet, but I'm just asking first, like, what can be the issues which can lead to the bile salt problems, as Kate mentioned?
So fat
Very nice,
metabolism.
Alicia. Ileal resection. Beautiful. Anything else? Anything else? If liver is sick, right? Yes, Bursu, go ahead.
I was going to say like a bile duct obstruction, like a
Bile duct obstruction, very nice.
Mhm.
Liver is sick, someone who's having cirrhosis or someone who's having hepatitis, how we had, we had a question in the clickers, right? So just be ready with all that stuff, By any problem, if bile salts are not there, they obviously not gonna emulsify the fats, right? Then comes the enzyme. So any gallbladder issues, if someone who's having gallstones, it obstructed the duct, the bile is not coming out proper, or liver is not working proper. So all those things you should be ready with. Okay, now let's go to chronic pancreatitis. We already discussed lack of bile. So all those issues will come, right? Someone is saying IBD. Very nice, Jay. Would you like to tell us what is happening? IBD. Jay is in the library. Okay, there is information which is destroying villi. Yes, very nice. Great. How about celiac and tropical sprue? Give me different reasons for celiac and tropical separately. So if someone is gluten antibodies, they are attacking the microvilli, right? So at any point of time, someone who cannot work on gluten or they are sensitive to gluten, they will have lymphocytes basically attacking the gluten in the gut, right? And that's how it's killing the microvilli. So you don't have as much absorption area to absorb things. So patient will have fats appearing in the fecal matter, right? Tropical sprue is something where they have had long-term infection in the gut, so bacterial overgrowth over the gut, which has killed the surface basically over time, and they can't absorb things really well. I think we are doing pretty good. Anything else that comes to your mind that we might have missed? Yeah, someone had said, Alicia had said cystic fibrosis. So, Alicia, would you like to explain it?
Oh, sure. So fibrosis, the acinar glands get clogged with the mucus, and so then you get decreased release again of
Ducts,
the pancreatic.
basically,
The
the ducts.
yes, get clogged.
Acinar glands, acinar cells, nothing is happening there. It's
Oh,
basically the
okay.
chloride channels in the ductal cells.
Okay, so you're
Remember,
still getting
we
the
talked
enzymes
about the
release.
duct. Yeah, we talked about the
Okay, they
ductal
just can't
cells.
get
Yeah,
out the
so the
ducts.
ductal
Okay,
cells gonna get clogged because the secretions are very mucousy, not the
okay.
aqueous in a normal scenario, how they should be, right?
And then that's why the enzymes can't leave because the ducts are clogged. Okay, thank you.
Clear? Is it clear or no?
Yeah, no,
You
that was
getting my
clear. Thank
point?
you.
Okay. All right, wonderful. Any other thing that we might have missed so far? I think we covered it all. Pancreatitis, Zollinger-Ellison.
Sorry to interrupt. Would it be ApoB deficiency?
Oh, beautiful, beautiful. That's what I was thinking. We missed something. Beautiful. Yes. So why do you need ApoB proteins? What do they do? Now you got to hit the answer too. Anyone? ApoB proteins you need to make the chylomicrons. What are chylomicrons? How do you absorb fats? Do you put them directly into your intestinal cells? Where are the chylomicrons absorbed into? Yeah, micelles will be picked into the intestinal cells, right? They are further packaged into chylomicrons, which are really big. So do you put them in bloodstream straight? No. Why? So chylomicrons are very big molecules, very big. They have cholesterol, phospholipids, ApoB sitting on them, and whatnot, right? So it's all packaged into like 1,000 angstrom big molecule, which cannot be sucked into the capillaries. Your capillaries are so small, right? So they'll be extruded through exocytosis into the lymphatic ducts first, right? And then from lymphatics, they'll be poured into the bloodstream down the road. Okay? Does it make sense? I think there is still, I mean, you all need to work on stuff yet. I am not satisfied with this session at all. I feel that there are so many lacunae in between that we need to cover. So sit down today after you're done with the classes and let's meet again at 9:30 and we're gonna have another set of questions coming for you. Yes? All right, so I'm going to leave you here, and somebody had asked about tonic and phasic contractions, and I'll bring it back at 9:30. Review or whatever we call it. But remind me in case we are going into some other direction and I forget it. Pester me, please. Okay. All right. Have a good day and see you all later at night.
Thank you,
Thank
Dr.
you.
Kaur.
Thank you.